Hi there, welcome back to my channel. It's been a bit of a minute. Been busy with quite a few things, school, starting work, kit and caboodle. So needless to say, with it having been quite a bit of time since my last video, I've also been able to make some headway in the project. Just to reiterate what that project is, my last video was on a EEPROM programmer that I was building. Originally, I believe in that video, I had it using an Arduino. And in this video, I want to give an update on that project since I have left the Arduino and moved on to a different board. Again, that's the point of the video, and I'll be demonstrating the progress that I've been able to make regarding the EEPROM programmer. This is going to be focusing on getting the data from my board to the chip, at least, if you will, the mechanics and the brain work behind it. So again, thank you for watching, and let's get right into it. Okay, so right here we have the board and the LED setup that I have. It's a little bit different. I made this prettier to see for you guys, as well as also, again, I think I remember in the last video it was an Arduino. This time it is now a MSP432 development board. I will explain why I decided to swap over to this guy instead of the Arduino. And when I say I will explain to it, I'm going to explain that right now. So the issue with the Arduino was that there's just too few pins, especially if I wanted to be able to use then UART on that guy. I would have been muffed. I couldn't do anything about it, and therefore it's very much so limiting. The reason why, therefore, having switched to this guy is, you can see too well, sorry for the focusing, GoPro does what it does. Got some pins here. Got one set of headers and another set. Now I got some more pinholes here. This guy has 10 sets of pins with 8 pins to a set. So quite a few, very nice and handy. The reason why using this board instead of the Arduino is because the number of pins gives me the breathing room, and because I want to introduce a MUX into my setup to be able to streamline when I make a read to my EEPROM. I can kind of serialize it, get everything all up in parallel into serial. The reason why, again, I'm doing all this is for getting that data from my board to the EEPROM. And my hopes is also that this will allow some more unique functionality along the way as I make this EEPROM. Well, not even just with this EEPROM programmer, because obviously I'll be writing it as a program, but I would like to hope to be able to incorporate this board in a project using the EEPROM. That's the hopes, at least. Now, what I want to do is take the opportunity to demonstrate to you what it is I have, after which I will then explain what is actually occurring, what I've done with my program, and kind of also illustrate the brain work that I have put into this in order to get it to display a single char at a time using LEDs. It will use the binary representation. Now, without further ado, the program. Fairly simple, fairly straightforward. What I've done here with this program is what you saw was the binary representation of each letter in the word contrive, as this whole project is very much so contrived. the brains of everything that's occurring that we see really occurs here. Obviously, I have some things defined up top, but here you see that I have two nested loops. This one right here is what I use to go through each char in my char array. And then this loop here is what I use to iterate through each bit of the char as represented by using this loop. And so each time it runs, it will take the least significant bit, put whatever it is, a 1 or a 0, put that onto my input, go into my shift register, and then it'll then bit shift the data of that char over to the right. So that way then I get the next least significant bit to compare, see if it's a 1 or a 0, and put that on to my shift register, all while of course shifting those values in that register to go to the next output pin. And so I will go ahead and show what I mean by this using my notebook that I've used to lay out this brain work for me to make sure I understood what's occurring. So first things first, this right here on this page was the early work that I had done in getting a single char outputted to the shift register and displayed. This was using the example of the letter H, which has a hex representation of 6, 8. And here's the binary representation. And so, as I mentioned before about looking at each index or each char and then bit shifting the value of that char over to grab the least significant bit. Here, starting with the letter H, I grab that, I put a 0 out onto the line and shift that in the shift register to move that along to be able to get ready and grab that next value, which is, after having bit shifted my H, is a 0. And then we rinse and repeat. Here's that 34, shift it, 1A. We're still grabbing a 0, bit shift. Oh, this time it's a 1. We put that on and rinse and repeat until eventually it is just all zeros, but this final 0 is representative of that first one as I had underlined it going through. On this page shows what it is you saw in terms of hex value on the LEDs. Series set for the first hex value of 6.3 and then 6F, 6E, and so on. And I will go ahead and show that using my breakpoint that I have set up in order to show that it is indeed working. I will show simply the 6.3, 6F, and maybe the 6E if I feel like it. Okay, so here we go. I'm now starting this, and I will note when I hit my breakpoint, and I will count each time we iterate through that nested loop, and that is going to be indicative of that bit shifting occurring. And finally, when I hit 7, 7 will be indicative of 8, right, as the first index starting at 0. All right, so we've entered the first loop. We're now in the nested loop, and we have just started it, so we are at 0. We've shifted once, twice, thrice, fourths, fives, sixes, and 7. So now what we're about to see will be the value of 6.3, or C in hex. If you remember, I said this, if I didn't say earlier, this bit represents the most significant bit, and this bit is the least significant bit. So splitting the difference, so it's 4 and 4. Here we have a value of 6, the 4 and the 2. And then over here we have a value of 3, the 2 and the 1. We have now moved on to the next index in our character array. And so now we're at index 1 and no longer 0, and we have entered into that nested loop. You have shifted once, and now we're about to shift a second time, and a third, fourth, fifth, sixth, seventh, and we're about to shift an eighth and output. And here we go. The next representation of a letter, which is O, and the hex value for O, 6F. Again, splitting that difference, still the 2 and the 4, and of course with it being an F, that is all LEDs lit up. I won't worry about showing the next one, as it obviously took a little bit of time, but you get the point. I can now run through. I'll go and reset the board just to demonstrate one more time. I can now output an entire word in LEDs, which again will be helpful for storing each letter in an address on that EEPROM, in hopes that maybe when I finally am able to get everything else figured out regarding the addressing in that MUX, you know, you gotta do it justice and burn Hello World as the first thing. So fingers crossed. Again, thank you for taking the time to watch my video and see the updates and progress that I've made on this project. Again, thanks to Ben Eater in his video and helping me understand some of the initial concepts that I needed to take this step forward and start to branch off and make it my own. Now I can be able to say that, you know, I did do this. It's been a lot of fun, been learning quite a bit, and it definitely helps in brushing up those, well, I'm just gonna call them computer concepts. So again, thank you for your time. I didn't do this in almost any of my videos on my channel, but I probably should. If you like the video and like what I'm doing, leave a like and a comment, subscribe to the channel. It's not indicative of whether or not I'm going to continue this. I'm going to continue to show forth this progress. It just simply helps knowing who else is interested in this. I hope others find this fascinating as I do. If not for the technological stuff that's going into it, it's the brain work and the conceptualizing that's probably some of the most fun I've had. So again, thank you, and I'll see you again soon.